Okay.
Oh, you started already?
Along with translations, reflections, it's not reflect ions. I think there just ended up being a space there. Reflections are also an isometry. Does anyone know what that word means? I don't know what it means either. Let's look it up. Look it up. Don't read my email. Don't read my email. Okay. Isometry definition. A mapping of a metric space onto another or onto itself so that the distance between any... This is boring. I think an isometry is probably the same idea as a rigid transformation. Do you guys remember what that means? What's a rigid transformation? Doesn't change shape or size. Yeah, I think that's the same idea it's trying to say. So if you want to erase isometry is the word that's supposed to fill in that blank, but if you want to change that to say rigid transformation, you could. So it still is the same shape and size, I think, is what they were getting at. Yeah. Reflections flip an image over the line. So let's go ahead and take this pre-image and flip it over this line. So what we're going to do is we're going to say, okay, B is about this far over the line. We're going to flip it that far over the line on the other side. Is that about the same distance, would you guys say? Yeah. Okay, so that's B prime. Okay, C is going to be the easiest one. C prime. Then... A prime? Did I do it pretty good? Kind of? It's very hard to do it when there's no grid. So just do your best. We'll pretend we all did it perfectly. Okay. So the pre-image is over here. A prime, B prime, C prime. This is the image. This is the after. Since they call that the pre-image, I always want to call this the post-image. Anyone else? Yes. Yeah. I don't know why they don't call it that. I guess it would be redundant. Okay. So we say that triangle ABC maps to triangle A prime, B prime, C prime. And then here's where they actually say it in words so that you can remember how we read that out loud. Triangle ABC is mapped to triangle A prime, B prime, C prime. A reflection involves a flip of an image, usually over the X or Y axis. Let's go ahead and label those in this picture. So this right here is the X axis. So sometimes they'll reflect a picture over the X axis, so you'll reflect it down or reflect it up. Or maybe the picture's partly up and partly down and you kind of reflect it both ways. That can happen. Sometimes they reflect it over the y-axis, so they kind of reflect it left and right. It may also be flipped over other lines, such as y equals x, or x equals 2. So the line y equals x, I'm going to write it right here, y equals x. This is y equals mx plus b, that form. And if you guys remember that form, we have to think about what is the number in front of the x. So if there's no number in front of the x, what number would it be? 1. And if we take the number 1 and we write it like a fraction, what fraction would that be? 1 over 1. And if there's no number after the x, what number is technically there? 0. So y equals x would have a y-intercept of 0, and it would have a slope of 1 over 1. So it would go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So it's possible for you to do reflections where you reflect it over that diagonal line. In fact, in Math 3, they do a lot of reflections over this diagonal line deliberately. Not any other line, they do this line specifically, and they kind of ignore everything else because it's something important. You'll learn about that a little bit later. So that's the line y equals x, and we remember that's y equals mx plus b form. Okay? They might do the line y equals negative x, which is similar. It's another diagonal line. It just goes diagonally the other way. We don't have to draw that one. We just know that that's another way you can do it. They might do the line y equals 3. Anyone know what the line y equals 3 looks like? Yeah. Yeah, so y equals 3 means that you're choosing a line where every single y coordinate for the point is always 3. So we have the point 0, 3, we have the point 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. When you have the line y equals 3, you're just saying every single point has a y coordinate of 3. So this is the line y equals 3. So we could reflect over that line. Y equals 3. And we could reflect over the line x equals negative 7. What does the line x equals negative 7 look like? Yeah.
The vertical line on negative 7.
And so if we graph the line x equals negative 7, we're saying every single point on that line would have an x coordinate of negative 7. So that'd be negative 7, 0, negative 7, 1, negative 7, 2, negative 7, 3, negative 7, 4, and it creates a vertical line. So all sorts of lines you can reflect over. We're going to come up with the shortcuts for a few of them, but obviously there's a lot of different lines you can reflect over. So we'll have shortcuts for a couple, and then the other ones, if they ask you to reflect over it, you're just going to grab a piece of graph paper and do it. Does that make sense? Or if you can keep it, you can keep track of it in your brain, you might mentally picture it and do it that way. But if you get confused, just grab graph paper and do it by hand, okay? All right, go ahead and flip the page. I think that's everything on that page. All right, so this one says triangle ABC. So let's go ahead and draw the triangle. We have the point 5, 0, that is A. We have the point 3, negative 1, that's B. And we have the point 4, negative 3, that's C. Now, if you want to have, I find it helpful to do my pre-image and my image in different colors. You can do that if you want, you don't have to, okay? It just kind of helps me think a little bit. So I'm going to switch colors to do, when I do my image on these. So they said we are reflecting over the x-axis. I'm not going to switch colors just yet because I like to count using pencil, and then I erase what I counted, okay? So the A point is right on that line of reflection. So when I reflect the A, it's not going anywhere. It's just going to stay right there, because if you think about the line of reflection as what you're kind of folding the image over, it's going to stay right there. Let me go ahead and draw this triangle. I didn't do that yet. I'll go ahead and draw it. Triangle. So what I'm doing is I'm imagining that I'm creating a fold right here on the x-axis, and I'm going to take this triangle and I'm going to fold it up over to this side of the picture. Does that make sense? I'm just going to fold it up over. So A is right there on the line of reflection. It's going to stay there. So I'm going to go ahead and draw this in red. And I'm just going to say, oh, that's my A prime. Okay. I'm going to grab my pencil again. Now I need to count. When I reflect something, I have to count straight towards the line of reflection. So C is 1, 2, 3 boxes away from the line of reflection. Can you guys see that? 3 boxes away. So I'm going to count 1, 2, 3 boxes, then I'm going to put my C prime right there. Okay? And then B was 1 box away, so I'm going to count 1 box away, and then I'm going to put my B prime. And then I will go ahead and write down my points. Now, I'm going to write down the coordinates because if we can start to figure out these rules, that's going to be beneficial to us. So for the A, we kept it exactly the same at 5, 0. I should be writing A prime. B prime, it was 3, -1 for the pre-image. Now the image is 3, +1. C was 4, -3. Now it's 4, +3. Okay, so there's our first reflection. You guys feel comfortable with that? Yeah.
Will it always give you a graph, like of the first image? Because I think it'll figure out what quadrant it'll be flipping into, and then all the numbers will change that.
It's
No, I kind of the rules.
the rules are not based on the quadrant. They're based on the type of reflection that you're doing. And we typically work with graphs first so that we can see how the rules work. And then after you know how the rules work, then you don't necessarily need a graph, but you might have one. All right, next one. Graph triangle ABC. So let's go ahead and graph those points, -5, 1. This time we're going to reflect over the y-axis. So there's A, B is -4, -3. C is +1, +1. Nope, I drew my C wrong. I did -1, +1. +1, +1. All right, so here is our pre-image. We're reflecting over the y-axis. So this time, instead of counting up and down, we're going to count left and right. Okay. So what should I do to find the image for C? What should I do?
Would it not become the -1?
Yeah, so it's right now it's 1 box to the right of the line. So we're going to go 1 box to the left. So that's C prime. Okay. How about B? Okay, so 1, 2, 3, 4. 1, 2, 3, 4. There's our B prime. Okay. And then how about A? Okay. 1, 2, 3, 4, 5. There's our A prime. And we can go ahead and draw the picture. And with reflections, a lot of times when you draw the pre-image and then draw the image, if you get something wrong, you may not be able to put your finger on what's wrong, but you can definitely, your eye will be able to pick up you did something wrong. You just may not know what it is. Okay, so let's go ahead and write down the coordinates for A prime, B prime, and C prime. Oop, not double prime. Okay, so A prime is right 5 up 1. B prime is right 4 down 3. And C prime is left 1 up 1. Okay. So let's see if we can figure out some of these shortcuts here. So when we did our reflection over the x-axis, we were reflecting up and down. So does the x value change if you reflect up and down? No, the x value is going to stay the same. So if we start with x comma y, the x is going to stay the same. What happens to the y coordinate? You reflect up and down. What happens? Yes. Yeah, it's going to change signs. So if it was up, it's going to move down. That changes it from positive to negative. If it was down, it's going to move up. That changes it from negative to positive. So whatever the y value was, it's going to change. So the shortcut is x negative y. Does that make sense? Pretty reasonable? Okay. Let's look at this one. So if we are taking the points and switching them from left side to right side, is the y coordinate changing? No. Okay. So we're going to say x, y. We know the y coordinate is staying the same. And then what's happening to the x coordinate? It's becoming negative. So either it was positive on the right side and it's becoming negative on the left side, or it was negative on the left side and it's becoming positive on the right side. So whatever you know about the x coordinate, it's going to change signs. Okay. So let's go ahead and write these abbreviations and write these rules that we know about the x-axis and the y-axis. Now, we had abbreviations yesterday for rotation. What letter did we use for rotations? R. So we know that reflection starts with R. So we know we want to use an R again, but we have to differentiate between reflection and rotation. So what about rotation did we use? We did rotation of 90 degrees, right? But we used a capital R. So when we do reflections, we're going to use a lowercase r instead of capital R. Does that make sense? That's how we kind of differentiate the two. So we're going to say lowercase r, x-axis. That's our abbreviation. So we're saying reflect over the x-axis, reflect over the y-axis. And then our rule for the x-axis is x comma negative y. And then for the y-axis is negative x comma y. Seem reasonable? Okay. And then reflection over the line y equals x, we're going to say lowercase r, y equals x. Now we say this is sub, so if you were to read this out loud, you would say lowercase r sub y equals x. That's how you say it when you're saying that you're like going down and writing it little. And then this rule is you switch them. So you do, instead of x comma y, you do y comma x. So if you reflect over the line y equals x, you're just trading your coordinates. Your x is becoming your y is becoming your x. Okay? Reflecting over the line y equals negative x is lowercase r sub y equals negative x. Again, the x and the y are switching places, but they are both changing signs. So this time we're going to say negative y, negative x. All right. How are your brains doing? Brains are okay? All right, let's go ahead and draw the line y equals negative x. So y equals positive x, we said, was that diagonal line that has a positive slope. Y equals negative x is this diagonal line that has a negative slope. I'm going to go ahead and graph it kind of a dotted line. The graph of the line is technically not part of the it's not part of the picture technically. Yes. Yeah. Yeah. We should figure out where on the window the glare is, and we should put a piece of.
A lamp back there.
Is it the lamp? We should figure out where the lamp should go. I do the lamps because I get migraines easily, and the fluorescent lights are what trigger them. So that's why I do the lamps. Yeah. We got the rules? We good? Okay. All right, so this is y equals negative x. Now, these, we already have the rule, so we can already use the rule to kind of switch the points, but I do want to show you how to do it graphically because this one's a little bit interesting if we do it graphically. So this one says parallelogram, so we know that when we draw it, it's going to be a four-sided shape instead of a triangle. So we got -2, 4, -3, 2, 1, 3, and then 2, 5, and we can kind of see that parallelogram shape. So -2, 4, there's A, B, C, D. And these are really kind of weird to reflect over the line because we knew that if we were reflecting left and right, then we just counted how many boxes to the left, counted how many boxes to the right. If we were reflecting up and down, we counted how many boxes up, we counted how many boxes down. This time we're reflecting diagonally, so we're going to count diagonal boxes. Does that make sense? We're counting diagonal boxes because we're reflecting diagonally. So, gonna mess with your brains a little bit. Are you ready? Can you guys see how A is one diagonal box? You see that? One diagonal box. Everybody see the diagonal box? Okay, so I'm gonna say A is one diagonal box across, so I'm gonna go one diagonal box, there's A prime. Now B is a weird one, it's not even a full diagonal box. Can you see it? B is like half a diagonal box. You guys see that? Half. So I'm going to go half a diagonal box on the other side. There's B. We okay with that? B was kind of a weird one. It's like half a diagonal box. There's B. Let's go ahead and count D. So we're counting straight towards the dotted line, which means we're counting diagonal boxes. This is the weirdest part, okay? So I got one diagonal box, 2, 3.5. Everyone see that? For D, I got 3.5. 1, 2, 3.5. Everyone see that? It is weird. So when I count the other way, I'm going to say half. 1, 2, 3. There's my D prime. I think the reason they gave you guys the shortcuts already is because they didn't expect you to count diagonal boxes. How many diagonal boxes is the C? 2. 1, 2, 1, 2. Now, we can just go ahead and use the shortcut. I'll do that in a second. So the shortcut for this y equals negative x was to just take each of your points and trade the x coordinate and the y coordinate and change the sign for each of them. So for A, if we trade each of them and change each of their signs, it should be -4, +2. Does that match up with the A prime we found? Yep. -4, +2, good. Okay, B, we're going to switch them and change their signs. So it should be -2, +3. Does that match up with what we found? Okay. C should be -3, -1. Does that match up with what we found? Okay. And then D should be -5, -2. Does that match up with what we found? Okay, so there's two ways you can do it. You can draw the line of reflection and count boxes, or you can use the rule. So it kind of comes down to what you're comfortable with, okay? Now, the next one is reflecting over the line x equals -3. We don't have a rule for that, so this is one where you would have to get graph paper out. You would have to do it by hand, or else you would have to just picture in your head, okay, how close is that point to -3? Okay, I'm reflecting it left and right. How many boxes is that? So you could do it in your head, but you'd have to be very careful, okay? When I got to these ones on the answer key, I did not draw them. So when you get to these on the practice assignment, let me know if I'm wrong. Okay? Say that again. Did you do it already? Look at you, Speedy McSpeederson. You can draw them. Yeah, we're about to draw it right now. Okay, so x equals -3 is the vertical line where all the x coordinates are -3. And we got the point -6, 2. There's A. -5, 4. There's B. And then -4, 3. There's C. Okay. I should also confess that I made the answer key for this practice assignment while I was watching TV, which we all know is dangerous. So don't judge me if my answers are wrong, okay? Just say, when you compare answers with mine, be like, Ms. Rice, my answer is different than yours. And then I'll look and I'll be like, oh, you're right. Let me go fix my answer key. You know what I'm saying? Okay, so let's do this reflection. How many boxes should I go for B? 2. B prime. How many boxes should I go for C? 1. You guys are like, we're tuning you out. We're just doing it. How many boxes should I go for A? 3. A prime. So just, I'm going to say this again, just in case you didn't hear it the first time. The reason I'm drawing the lines of reflection kind of dotted on here is because they're technically not part of the answer. They're not the pre-image, they're not the image, so they're not actually part of the answer, so I'm drawing them dotted because it's not actually part of the graph. Does that make sense? So technically they're like invisible. So typically in math, we draw invisible things as dotted to be like, hey, it's there because it helps me, but it's not there for real. You know what I'm saying? Okay. And let me go ahead and just write these points down. So A is 0, 2. B is -1, 4. And C is -2, 3. So if you were doing these without drawing it, you could see that the line of reflection was at -3. -6 is 3 spaces to the left of -3. So this needs to be 3 spaces to the right of -3. Does that make sense? B was 2 spaces to the left of -3, so B prime needed to be 2 spaces to the right of -3. C was 1 space to the left of -3, so C prime needed to be 1 space to the right of -3. So when I was doing some of these, because if you look ahead in the packet on the practice assignment, it says like C number 13 and number 14, it tells you to reflect over these lines, and then it gives you no graph and no space. You can do those on graph paper, just because those are hard to do without drawing, or if you want to think about it the way that I just described, you can think about it that way. That's the way that I was thinking about it, and that's how I did it without graph paper. Is I was like, okay, it's a vertical line, so I have to think about moving it left and right, how many spaces away, and then I mentally counted. That's how I did it without drawing. Does that make sense? It is optional. You can do it in your head, thinking about counting, or you can draw it out if that's too much thinking in your head for you. Again, I did it while I was watching TV, so if my answers seem like they're not right, feel free to have me check my answers against yours. Okay? We're going to start it in class, and then whatever you don't finish in class will become homework. Okay, we have one more sample problem before practice starts. Okay, so this says, take these points, reflect them over the line y equals x. What's the shortcut for y equals x? They just switch. The x and the y coordinate switch. So we're going to say f prime is -2, 5. R prime is 10. Oh no! Come back. Okay. E prime is 12, -5. D prime is -3, 0. Ta-da! Wasn't that so fun? We had such a great time. What a great time we had. That was so great. Oh, so fun. Okay. And so now you're working on the rest of it for practice. Cool. Okay, you're about to hear my voice. Don't be upset.